In this video, we will learn how to use the mock open source Python package to debug our shell. The mock package allows us to simulate the use of Cloud Shell and therefore is useful for debugging early stage shells which are not yet ready to be installed on Cloud Shell. For example, you have not yet developed critical shell components like communication with the device and auto discovery, or you're still developing the component or command you want to test, but are not sure what information the command will need. When debugging, the mock code will run instead of the shell's default initialization commands and will call the commands you want to test. When shell development is finished, you can leave the mock code in the shell as Cloud Shell will ignore it. To use the mock debugger, you need to add the mock code to the shell and specify some details. Then, specify the attributes or commands you want to debug and add your breakpoints. To illustrate the use of this method, we will create a generic resource shell in Shell Foundry. To set up the shell for debugging, open the shells folder in your IDE and associate it with an empty virtual environment. Make sure to install the shell's requirements from the shell project source folder. Open the shell's driver py file and install the requirements. Scroll to the bottom. Make sure the line is not indented and paste the following code. Note that you can also run the debug code from a separate Python file to keep your driver clean. Since the mock package is not in the shell's runtime, install the package. In PyCharm, click the package name, press the Alt and Enter keys, and install. Replace generic resource with the shell name, as displayed in the shell definition YAML file. Replace generic resource driver with the driver's class name. Leave reservation ID for now. We can use this attribute to test a shell resource in a Cloud Shell sandbox. But for now, let's debug with the IDE. Let's set an address and a name for the resource. Since we are debugging a new shell that does not require access credentials, we can leave these attributes as is. But for shells that require access, you will need to provide the information relevant to your shell. Let's create an example command that prints the resource's name from the resource context. In the driver py file, add the command and set the shell's name. In this command, we will use a helper that resides in the generated data model file. Run Shell Foundry generate to create the data model file, and uncomment the data model import line at the top of the page. At the end of the mock code block, add a result variable that will receive the example command, and set a breakpoint on the next line. Debug the shell. In the debug pane, scroll down to result to see the command's message. You can also print the result before the print done line and have a breakpoint after it to see that result in the console instead of the variables pane. Now, let's say you want to debug a command that uses the Cloud Shell API. If this is the case, the command will need to create an API session. To make use of the API, add the Cloud Shell Automation API package to the requirements file, with the minimum and maximum Cloud Shell versions that it should support. For this demo, we're using Cloud Shell 8.3. In the driver py file, install the requirement, and add the following line to import the Cloud Shell API session class from the package. Add the command to the shell, and set the shell's name. This command is very similar to the previous example command, but this version also creates the API session and retrieves the included state of the resource. To create an API session, we need to generate and pass a Cloud Shell authentication token. To do so, add the following to the mock code and set the Quali server address. Provide a name of an existing resource in Cloud Shell. Cloud Shell will return this resource's included state. Add the line that retrieves the result, and debug the shell. In the debug pane, scroll down to Result to see the command's output. Now, let's see the shell's discovery results. Discovery is responsible to load the resource's structure and attribute values from the physical device. It is defined in the shell's getInventory function. At this point, getInventory returns an empty resources list and an empty attributes list. But in reality, these lists will be populated with the resource structure and the attributes on the different resource levels. To debug the getInventory function, add the following line, and debug the shell. Scroll down to the result. The attributes and resource lists are displayed. Next, let's modify the getInventory command to create a port. Debug the shell. Expand the result. The attributes list displays the shell's attributes, and the resources list displays the root resource and the port we created. Let's also print the shell's address and user. Debug the shell, and open the console to see the messages. This concludes our video. We hope you enjoyed it.